Imagine this. You or someone you love has a rare disease. You've seen specialists, done test after test, maybe even had your whole genome sequenced, and still no clear answer. Part of the problem is that our DNA is full of tiny spelling changes, thousands of them. Most of those changes are harmless, but a few can completely break how a protein works and cause serious disease. The hard part for doctors is figuring out which change is the troublemaker. Now, researchers at Harvard have built an AI model that helps with exactly that. In simple terms, it learns the language of proteins and combines that with real world data from human populations to predict which DNA changes are likely to be dangerous. Here's how to think about it. Every gene is like a sentence that tells your cells how to build a protein. Over millions of years, evolution has edited those sentences. Some changes are okay, some are tolerated, and some are basically never seen because they're too harmful. This AI model has been trained on huge amounts of protein sequence data, so it starts to understand what a normal, healthy sentence looks like, and which edits look suspicious, like typos that would probably break the meaning. Then it lines that up with data from real people. Which variants are common in healthy populations? Which ones almost never show up? Which ones seem to pop up in people with certain rare conditions? For each variant, it gives something like a score. This one looks benign, this one looks questionable, this one is very likely to disrupt the protein in a way that could cause disease. For families stuck in a diagnostic odyssey, that matters. Instead of a doctor staring at a list of thousands of variants thinking, where do I even start? They can use this AI to get a ranked shortlist of the most suspicious ones. In studies, this kind of model has already helped reclassify some we don't know variants as likely disease causing, identified new variants that explain previously unsolved cases, and even pointed to new genes that might be involved in specific rare disorders. But it's really important to say this. It does not replace doctors, genetic counselors, or lab tests. It doesn't say, you definitely have this disease. It says, given everything we know about proteins and human variation, this change looks risky. Please look here first. So instead of years of random guessing, you get focused clues, tests to run, family members to check, proteins and pathways to study for future treatments. If you've ever watched someone bounce between specialists without answers, you know how brutal that uncertainty is. This AI model doesn't magically cure rare diseases, but it can help turn a massive, confusing pile of DNA data into a clear list of suspects, which, for a lot of families, could mean getting a real diagnosis faster and being one step closer to the right care or the right clinical trial. So let me ask you this. If you or someone you love was stuck in that kind of rare disease mystery, how would it feel to know that an AI system like this was sitting next to your doctor, not replacing them, but helping them find the right variant in that haystack just a little bit sooner?